네, 대단히 감사합니다. 저희 두 번째 세션 시작하도록 하겠습니다. 여러분 착석해 주시면 감사하겠습니다. Ladies and gentlemen, welcome to Session 2 of World Strategy Forum 2010. 이번 세션은 글로벌 경제 위기 이후에 다시금 제조업의 중요성이 부각이 되고 있습니다. 그런 가운데 세계 제조업 어떻게 변화할 것인가 하는 주제로 진행이 되겠습니다. Ladies and gentlemen, the title of this session is What Will Change Global Manufacturing? Please allow me to introduce our main speaker. 이번 강연자는 후지모토 다카히로 도쿄대 교수이십니다. 교수께서는 하버드 경영대학원에서 경영학 박사 학위를 받으셨고요. 제조업 경영 이론의 세계 최고 권위자로서 현재 도쿄대 제조업 경영연구센터의 소장으로 재임하고 계십니다. Our speaker is Professor Fujimoto Takahiro, Professor of Tokyo University. I understand that his CV will be appearing on the screen. And he is renowned as one of the foremost authority on manufacturing management. 여러분, 후지모토 다카히로 교수님을 박수로 맞이해 주십시오.
Thank you very much. 안녕하십니까? Well, it's really, I'm sorry, I have to speak in English probably, because there's no translation. And time is limited, it's only 45 minutes, so I have to go very fast through my slides. But, it is really great honor to me to be here. And, I've been here in Seoul since 1980, so 30 years of experience going back and forth. But the Korean change of economy is really spectacular, and so is the company's growth. Today, I'd like to discuss a bit about what will change the global manufacturing, including, of course, Korean and Japanese, and of course, American and other areas. Of course, time is limited, so I probably have to focus on Asian countries. But let me go pretty quickly through what I'm going to talk about today. Well, first, since this is the main topic is globalization, we have to start from what is globalization. And it's very simple that the globalization of economy is the situation where goods, information, money moves across borders. So that's very simple definition. But the country's comparative advantage is said to be determined by sort of not so easily movable things, in other words, sticky things, which is not easily moved across borders. And of course, traditional economics said it is labor or it is capital. But in more recent years, capability of the organization, I think, is another thing. For example, where Toyota has its own capabilities, they try to transfer this capability to American factories or Chinese factories, and they can do this kind of transfer of knowledge and capabilities to some extent, but not quite completely. And the same thing will happen probably in that, like Samsung has its own capabilities, and Samsung will try to transfer that knowledge to other countries, but not 100% probably. The same thing will happen to Hyundai Motor Company. So capability of the organization may be a very important source of the comparative advantage. And we say this because now, when economy is globalized, international division of labor will be one of the major results. Well, this is what David Ricardo 200 years ago said very clearly. And since then, we were always discussing that, well, if the trade becomes freer, then the trade will be based on comparative advantage, based on the international division of labor. But it didn't happen in a complete style in the last century. Last century was a century of great wars and cold wars and North-South problems, and trade wars. All kinds of big events happened which hampered the globalization of economy or freer trade or expansion of trade. But this century may be different. This century, as many scholars and specialists are predicting, this century may become the century of freer trade. If that is the case, then we have to really look at our own capabilities and our own competitive advantage, because trade will be expanded when different countries has its own capabilities, and different countries create different competitive advantage in different products and services, and trade with each other. Okay? And that is very, very classic notion of comparative advantage. So we'd like to discuss this in this presentation. And another important thing is intra-industrial trade. It is not just a trade of like we exporting steel and importing rice, something like that. It is really the situation where, for example, in between Korea and Japan, Korean companies like POSCO will export the sheet steel for the automobile, but Japanese companies like Nippon Steel or JFE will also export the same type of or similar, very similar steel to the Korean companies. So we are exporting steel and importing steel, exporting cars and exporting cars. So intra-industrial trade is very common in this century. So we have to understand why this is happening and where we are going, and that's all about global manufacturing. So global manufacturing. For an industry like Korean steel industry, Korean car industry, semiconductor industry, it is nothing but global trade of manufacturing goods. But for a company, it also means that global deployment of manufacturing sites, because companies can go across borders. By definition, Korean, for example, the car industry cannot go across borders. But Korean car company can go across borders, and that's exactly what's going on now. So, globalization has different meaning to the industry and to the company. So, textbook of the international economics and business will always have argued the prevalence of free trade and multinational enterprise for many years. But this actually never happened on a full scale in the last century. This century may be the time when we really see what textbook was saying for many, many years, which is freer trade and trade expansions and the international division of labor. So, compared with that, if you look back what was said since the 2000, we had many interesting hypotheses popping up one after another. But most of these extreme hypotheses sort of collapsed, turned out to be wrong when like IT bubble collapsed and financial bubble collapsed. And what's remaining is pretty ordinary, like common sense kind of ideas that 21st century will be, more or less, again, the global trade expansion and ever stricter environmental constraints. Maybe those two trends will be the common factors to what we are going to see in this century, wherever it is, Korea, Japan, or America, or China. So, in order to understand this kind of trade phenomenon or global manufacturing phenomenon, we probably have to go down to the factories or technical centers. Well, we can see this phenomenon from very high level, like 30,000 meters high. We go up and then they look at the Korean economy as a whole, Japanese economy as a whole, or a world economy as a whole. That's one way of looking at the things. For example, if we go up and see the macro trend of the Japanese trade structure, for example, right now. Last year, well, many of the Japanese media were saying that, well, Japanese companies losing one after another. So, sooner or later, the Japanese manufacturing will disappear. That kind of argument is quite common among the news media. But if you look at the statistics, looking at the whole pictures, then Japanese are still exporting about 50 trillion yen. So it's about probably around 500 or more trillion won, which is over 10% of the Japanese GDP. And in very high yen, now it's around 90 yen per dollar. It's still trade surplus of about 6 trillion yen. So, when everybody was talking about, Japan is losing, Japan is, going down, well, our manufacturing disappearing. Actually, if you look at the statistics, something quite different is going on. And when you go down to like 5 meter, 1 meter, I go to the factories almost every week. And I see small shop owners in many areas. Of course, I come to Korea and see those people, and also I go to China and America. I go everywhere and see the factory people there. And in certain areas, there are some companies which are doing very well. Of course, when the company is not doing well, then they speak up and say, "Hey, please help us." So, the people in the factories which is not doing well will always, be very visible. They say, "Hey, please help us." But when you are making profits, they say, actually, our company is making a record high profit this year. But please don't say to Toyota, don't say to Honda, because then they will come to us and say, "Hey, lower the price." So they never come. So all the good people, the companies which are doing well are very silent. So there's always this kind of bias. So we have to really look at what's going on from the 30,000 meter high level on the one hand, and also 1 meter high level. So going back and forth to see the reality from many different point of view. And to do this, we call this kind of approach field-based view of industries and firms. You have to really go up and down, and particularly you have to go down to the factory level and visit the factories, see what's going on there, talk to the people there, and then they get the reality. And through this kind of analysis, two major notions, concepts came up. One is organizational capability in manufacturing, and the other one is architecture. The architecture is, as I say here, the way design elements, that is the functional or structural process elements, are divided and connected to the whole. In other words, the basic way of thinking of engineer's mind. That is called architecture. And of course, capability is the capability of the firms and factories and technical centers. So, putting all these things together, what will change the global manufacturing? We will say that, when architecture changes, when capability changes in each countries or each factories or each products, the comparative advantage of individual companies and factories may change, and that may change the whole pictures of industrial structure or trade structures. So, in order to understand this, I would like to propose one alternative way of looking at the industry, which is a new approach to analyze the global manufacturing. And this is a kind of evolutionary framework, evolutionary economics framework of capability architecture fit, meaning that when architecture of the product and capability of organization sort of fit in a dynamic sense, then that factory or that company is more likely to have export power than otherwise. This naturally leads us to the design-based view of manufacturing. And sometimes we call this monozukuri. Monozukuri is not something special. Monozukuri is a very common thing. It is just a broad definition of manufacturing. But somehow we have this word, monozukuri, in Japan, but this word is not in the dictionary of Japanese language. So we have to go down to the factories and talk to the people and understand how they use this word. And it turned out that this word is much broader, I would say, than the concept of manufacturing or production or operation. Probably all these concepts together, monozukuri is a very broad concept of manufacturing. So we tend to use this word, but you can just simply think that this is a broad way of defining manufacturing. Okay, and then capability of manufacturing sites evolves over time. So it changes over time. Okay, and also architecture also changes over time. So both things are evolutionary. They are changing over time. But sometimes they match each other and then create export power. So this kind of dynamic fit between capability and architecture through comparative advantage of design and production sites affect global patterns of manufacturing configuration and trades. So this way, we'd like to go back and forth between 5-meter high level, just looking at the reality of the factories, and going up and look at the macro statistics and macro structure of the companies. That is the approach that we are using in the past maybe 10 years. By the way, I'm leading a center called Manufacturing Management Research Center at Tokyo University. And this is a center where we have lots of communication with the scholars and team-based analysis, team-based research of the factories, and also a lot of collaboration with the factories and firms. Actually, including, many of them are Japanese, but, actually, we have a close research connection with Korean companies also. Because our research team at MMRC are also international. We have 2 associate professors at our center. Both of them are Korean. No Japanese, but 2 Koreans. So our team itself is very international. So that's the way we do the studies. Team-based field research, which creates something which we hope is new to the audience. So this is the whole picture. On the left-hand side, the yellow one is capability. On the right-hand side, another yellow one is architecture. And architecture and capability may fit, and when there is a fit between the two, then it's more likely that the comparative advantage will come up and will show up. And of course, behind capability and architecture, we have the environmental sort of factors that may affect the 2 elements. So like capability building environment, capability building competition, capability building capability on the left-hand side. And right-hand side, we have constraints of market, society, and technology itself. So all these things affect the nature of the architecture on the one hand, and the nature of the capability on the other hand. So, one by one, from now on, I will go very quickly through the components of these things. First of all, design information view of the manufacturing. Here, the idea is to combine the engineering idea of design and economics ideas of trade. Because trade theory in the past 200 years didn't really pick up the concept of design on a full scale. But we would like to combine the design concept which is coming from engineering school and trade concept, which is coming from economic school or business school, and put them together to create some kind of additional explanatory power to explain what's going on right now in the global economy. Okay, here are the backgrounds of the theories. Of course, technology operation management is my area. Evolutionary theory of the firm is another important one. Resource capability view of the firm in strategy management, and also product process architecture, which is probably the theories of design, which is coming from probably axiomatic design theories of engineering. So we would like to really pull together engineering ideas and economics ideas together. And the result is this fit between organizational capabilities and architecture of the product and process, which may affect the power of the industries in each region. So why Korean semiconductor industry is so strong, why Japanese PC industry is so weak, why Japanese car industry is still doing well so, why Japanese semiconductor industry is weak, but the semiconductor material industry is strong. All these things may be explained in this kind of framework in a better way than previous framework. That's the hope that we have now. Design information view of manufacturing. The key concept is this: but the source of the value is design information. For example, we have like cup here. This is designed, of course. So this is artifact, and this has blueprints probably. There must be some design information behind this in a computer or on the paper. There must be design information which governs this cup. And at the same time, this is the material of this cup is glass. Okay, so this kind of product or goods are always a combination of design information and its media. So we always start from this kind of ideas. And the major source of the value added is probably design information. Okay, so value added is nothing but design information. That is our sort of notion of broad-based manufacturing concept. So this yellow one is design information, and the white one at the bottom is a medium. And actually, this kind of idea originally came from probably Aristotle, the great Greek philosopher 2,000 years ago, who said everything is a combination of form and its material. And in modern terms, we can rephrase it as all kinds of artifacts, all kinds of products, and service even, are the combination of design information and its media. If we say manufacturing covers these flows of design information, so this means that, manufacturing, or in a broad sense, or monozukuri, is nothing but creating good design information that satisfies and enthuses and entertain customers, and its media. The media can be intangible or tangible. If the media or material is like glass or plastic or steel, something tangible, then it's manufacturing. But if it's the media is intangible, like the electronic waves or like vibration of airs, like this, then it is service industry. So maybe I'm now standing up here as service workers, because I'm now speaking based on my design information, but I'm trying to transfer and convey this information to you through intangible things, or this vibration of airs. Okay, it's intangible, so this is service industry. Okay, so whatever it is, service industry or manufacturing industry, they both follows manufacturing concept. That is why company like Toyota can teach how to do manufacturing better to companies like post office or supermarkets and many other service sectors. So now one of the hot issue is how to transfer Toyota type manufacturing concept or knowledge to the service sectors. And it is quite logical because, again, the essence of manufacturing is not cutting things or shaping things, things like that. It's not really cutting materials. It is about creating design information, good design information, and it's good flow to the customers. Okay? So this is all about the monozukuri or manufacturing. So for example, in this case, we have a flow of these artifacts starting from development and then production and sales. Between production and sales, there are material flows. This is white flow. But yellow flow, look at the yellow flow. Yellow one is a flow of design information. And Toyota called this flow of value added. Flow of value added. And when it's flowing, the company called it value adding time. When this yellow, flow of design information is not flowing, then Toyota calls it muda. Muda means waste. Or minimizing waste and creating good flow to the customers. That is basically what Toyota system is all about. And so actually Toyota is one of the company which really emphasizes this value-added flow, which also means information flows, design information flow to the customers. So creating good design and its good flow to the customers is the whole objective of manufacturing. So, again, product development is nothing but creating good information, good design information, which entertain the customers, which sort of excite the customers. And then we also have purchasing. Purchasing people get the materials or media from outside. And production is nothing but like marriage of the design information and its media. So, for example, in stamping, what's going on is nothing but the transfer of design information from dies to sheet steel, maybe 0.8 millimeter sheet steel. Okay, so every time you have the stamping, the information which is embodied in the die will be transferred to the sheet steel. And when it's happening, it's called value adding time. Okay. When it's not happening, like die setup time, breakdown time, and other sort of time when this flow is not happening, we call this muda. Muda means waste. So minimizing waste and creating a good flow to the customer. That is all about the manufacturing in a broad sense, and that means monozukuri. So again, here there are 4 dies, and 4 dies. When each has a stamping operation, 1, 2, 3, 4, and then these design information is transferred to sheet steel, and that obviously creates values. So this kind of ideas of transferring information, design information, and creating good flow to the customers is applicable not only to the manufacturing on the upper side, but also the sales and supermarkets, restaurants, or even financial office. Actually, we have Manufacturing Management Research Center again at Tokyo University, and our customers, our sort of collaborating companies include not only manufacturing companies, but also all kinds of service companies, like dealers of motorcycle, post office again, and insurance companies. They all can sort of improve their performance by introducing some part of this manufacturing concept or a monozukuri concept. Second, since time is limited, please give me the red card or yellow card when time has come, because I'll just keep on talking otherwise. Organization capabilities. Well, again, this is kind of routines which controls design flows again. Good design and its good flow. Okay? So we are talking about this left-hand side of this total structures. And organization routines, if you go back to famous Nelson and Winter book in 1982, it is a routine is nothing but repeated control of design information flows. So something which controls design information repeatedly between productive resources. So from one station to another station, from worker to the materials, from machine to the materials, from something to something. I mean, from some kind of productive resource to another productive resource. So organizational capability is nothing but a system, total system, collection of the routines. The system of routines which create, again, good flow to the customers. Good flow means short lead time or high productivity or high manufacturing quality and others. So again, good flow is a key word, and the good flow has to reach the customers. Otherwise, the manufacturing has no value. So, if you take a look at the Toyota case, by the way, I have to talk about the Toyota quality problem probably today. But just one comment is that, I took a close look at 3-4 cases of Toyota's quality problems. They are all design quality problems. That means that it's not manufacturing quality problems. So, but Toyota's quality problem doesn't mean that Toyota production system collapsed or Toyota's factory capability collapsed. Actually, to check this, I always go to the real factories and then really take a look at the reality. So I'm now almost every week I'm going to Toyota factories now, and from 7 o'clock to 5 o'clock, I go there and attend the morning meeting and talk to the people and just watch the factories overall from 7 o'clock, 8 o'clock to 5 o'clock, and as far as I see the factories, their capability is okay. So manufacturing is okay. Design is a problem. So I would like to discuss why this is a design problem later on. But let's keep on saying that Toyota production system itself, I think, is still active and alive as far as I see the factories. So Toyota's manufacturing capability again means dense and accurate information transmission between flexible productive resources. I mean, this is a bit abstract way of expressing what's going on. But that simply means high productivity and short lead time and higher manufacturing quality at the same time. And one of the essence of a Toyota system is to take a look at lead time first. They say, don't look at the cost. If you want to control the cost, don't look at the cost. That is a kind of interesting paradox of a Toyota system. Because if you take focus on lead time, then that means you have to focus on creating good flows first. If you have a good flow, then you can easily see bad flow. If you can see the bad flow, then you start problem solving from there. So this is a way to reveal the problems. Unless you reveal the problem, you can't solve the problem. So you have to force yourself to find the problem by creating good flow. Because good flow makes a bad flow visible. That is a kind of paradox of the Toyota system. So, I would skip that one, but, actually, the red part is value-adding time. And this bar up there, around the red one, is the working time. So it's usually the case that if you are working for 8 hours, your value-adding time is usually only 2 hours or 1 hour. So if this 1 hour of value-adding time becomes 2 hours by Kaizen or improvement activities, then you can double the productivity. If it's 3 hours, then you can triple the productivity. On the receiver side, this blue one is value-adding time as a part of the lead time between the material to the completion of the product. It sometimes takes 1 month. Okay, let's take it takes 1 month. Mr. Ono, who created this system, Toyota system, said, if you have a really good factory, then this blue part, okay, is about 1 out of 200. So that means 0.5% over the total lead time, if your company is really good. Okay? That means if you have a really good company, then value adding time, the time when value is added is only 1 hour out of 200 hours. Okay? So this is why Kaizen or improvement is endless. And this is why sometimes shortening lead time by 20 times is possible. Or raising the productivity by 2 times, 3 times is sometimes possible. Because this value adding time is such a small portion of the total working time. So here is routines of Toyota systems that I counted. I can count probably about 200. Toyota people say that there are 400 routines. I can't count 400, so I have to really learn more. But there they have 400 different routines which create good flow to the customers like this or like this. And as a whole, production and development purchasing, they all deal with how to create good flow to the customers. Okay? And this is all about the capability. And usually this capability is made by a teamwork of multi-skilled workers. And not only that, but we have routinized manufacturing, routinized learning capabilities. So routinized manufacturing means that to repeat good flow to the customers like 100 times, 1 million times per year. And routinized learning capability means the capability to make about 600,000 times of Kaizen per year. And evolution capability is the capability to make evolution happening through 70 years or so. So, although Toyota made a very big mistakes, these things are still seems to be functioning. So we still have something to learn from this company. And also, if you look at these capabilities, then history matters. Well, I will skip that part because it's a bit theoretical, but evolutionary economics framework fits very well for explaining this kind of phenomenon. And one thing which was very clear to us is that after the World War II, since Japan lost the war and they started from scratch, we had to rely on the high growth era of 1960s and 70s without inflow of immigrants. Okay? When high growth is happening, probably Korea also had to grow without the big flow of the immigrants. But America is different. America is the country of immigrants. So when America was growing very fast, then American economy was relying heavily on the massive inflow of immigrants. So that difference of histories really created different types of organizational capabilities. So that's why American capability and Japanese capability are very different. And Chinese also has different histories. So their capability is also very different. So we all, each different countries has different histories behind. So that may create different types of organizational capabilities, and that may create different types of products which each company, which countries has a competitive advantage. So let's skip that part because it's too theoretical. If you look at the capability, then capability is a source of the competitiveness. If you look at this part, we have to really look at capability which creates productive performance, which creates market performance, which create the profit performance. So we tend to say that, profit is important. Profit is important, but don't look at the profit only. You have to look at this flow all the way from capability building to enhancement of productive resources, productive performance, and then market performance, and then profit performance. Actually, Japanese companies are not so good at the right-hand side. So on the left-hand side, Japanese companies are still doing pretty well in terms of productivity or lead time. But sometimes the profit is not good. So Japanese companies are, tend to have this strength and weakness. Strong factory, weak headquarters. Strong factory, weak headquarters. And some Korean companies have very strong headquarters. Okay. So that is a strength, and our weakness sometimes is this weakness of the factory. Weakness of the headquarters. Okay, compared with, for example, Korean companies or American companies. One thing which is really behind the Toyota problem is that recent trend of product development performance is that actually increasing complexity makes the lead time longer. Okay, 5 years ago we were saying that lead time for product development was getting shorter and shorter, from 20 months to 18 months, 18 months to 12 months, and 9 months. Everybody was talking about very optimistic view of shortening lead time. It's not happening. It's not happening. It's around 20 months, and now, it's not going down. Why? Because capability building and complexity will increase. Two things are going at the same time. Okay. Right. So, this is our measures of productivity of engineering of cars. Okay. Japanese numbers and Korean numbers are very similar. So Korean and Japanese are very strong in this term. But this number, I'm not checking the Korean numbers, but probably Japanese numbers and Western numbers are both going up, not going down. That means the productivity is not going up, but productivity is going down. Okay. Why? Because we are facing this gigantic monsters called complexity. Maybe in the next 10, 20 years, we have to face this monster. Complexity. Okay. And that makes gigantic and complex control systems, softwares. Now the cars has more than 10 million lines of software code. Okay. Gigantic. 3 times, 4 times as big as the jet fighters' control systems. The one car has this kind of very, very complex things. And of course Toyota's problem happened because of this complexity. The fourth thing, product process architecture. On the right-hand side, what we have to see is, going back to the design theories and look at the relationship between functions of the product and structure of the product, like components of products. For example, the cars may have functions like fuel efficiency, environmental friendliness, and performance, fuel efficiencies, safety. All these things, those are the functions. And the car also has components like engine, transmission, body, chassis, suspension, etc. So the question is, those functions and those structures, how they connect with each other. And we have, famous 2 different types. One is modular architecture, where there is a nice one-to-one correspondence. It's very simple relations between the structure and functions. So we call this kind of simple design, modular design. And the next one, which is car, basically, is a spaghetti type of relationship between components and functions. And this is called integral architecture. Car is a typical product of integral architecture. PC is modular. That's why Japan is not strong in PC, but fairly strong in the car industry and other integral architecture products. So, for example, this is sheet steel, which is exported from Japan to Korea, outer panel. And this is sheet steel, which is coming from Korea to Japan. There are lots of sheet steel now exported from Korea to Japan, but there are different types. This is more integral, and this is more modular. So we may explain why Korean is stronger in certain types of steel. Japanese are stronger in other types of steel, and we are sort of mutually exporting with each other. Okay? So we have to really look at this kind of reality. And if you take a look at the cars, for example, this yellow one is integral architecture product. So car is typical integral architecture products, and mainframe computer is closed modular, and PC is open modular. And these are the products where Americans and Chinese are very strong. Okay, and these are the products which now Japan, Europe, and now Korea, are getting stronger. So, well, depending upon the architecture of the product, different countries may have comparative advantage, and that may be the source of the trade. That is overall views. And since the time is limited, I have to skip this theoretical part, but I would just simply say one thing, which is if you go through this kind of economic analysis, one thing which becomes pretty clear is that architecture is determined by market. Architecture is determined by market and society. So if a market and society is strict about the performance of the product will become integral. If the consumers are strict or emphasize cost or price rather than performance, then it may become more modular. Okay, so but depending upon their types of the customers, the types of the product which the customer choose may be different. Okay, and based on that, the people may choose market or organization as the coordination mechanisms to handle this kind of products. Okay, I will just skip that part. And finally, well, in 5 minutes I have to talk about that. Capability architecture fits. Okay, overall, if you look at the capability of the product very carefully, going down to the factories and look at the product one by one directly, and then also visit the factories and take a look at their organizational capabilities and the change of the capability over time, evolution of the capability over time, then we may be able to sort of look at sort of predict what kind of manufacturing will go to Korea, what kind of manufacturing will go to Japan, and what are the products where Japan and Korea will compete with each other. And on the Japanese side, we have this hypothesis that because of the history, again, Japanese are team-oriented, and team-oriented companies and factories are stronger in integral architecture products. This is a logical sort of result of the economic analysis. So the more integral the product, the higher the export ratio. We tested this hypothesis, and generally speaking, it was the case. This is assembly products. This is a process product like chemical. In both cases, the more integral products were the products that the Japanese companies tended to be good at. Now, Korean companies is coming to this area, so the competition in this area may be tougher in the next 10 years or so. Application, Toyota quality problems. Well, I can use the same kind of analysis, showing that on the right-hand side, what was happening was complexity, overwhelming complexity, because of this huge safety and environmental pressures. And on the left-hand side, yes, Toyota was capable of handling this kind of complexity, but Toyota was probably overconfident. Too confident that they can handle all kinds of this complexity. Wrong. Even Toyota, which is very high in capability, couldn't handle all this complexity, overwhelming complexity which was coming to the industry. So this happened to Toyota, and Toyota made a big mistake. But overall, this problem of how to handle complexity is a problem of all companies, all automobile companies, as long as they are selling something to the advanced nations or advanced car markets. So this is a kind of a problem that is shared across all the companies, I think. Toyota made a mistake this time, but other companies also have to be very careful not to be trapped by this pitfall, like Toyota. I'll skip that part. And Asian industrial performance. Well, this is very, very simple description of how history created the capabilities country by country or region by region. Japan is probably one of the major center of integral architecture products in the Pacific Rim. Europe is another area where integral architecture is the source of the strength. And China is very modular for another different types of history. And America also was very modular. India, I'm not sure. Bangalore is very modular, but the rest of the India may be more integral than China, I would say. Well, I just visited there and took a look at many factories, and my tentative impression is this. And Taiwan is in the middle, and Taiwan can do anything. I mean, it's in the intersection. And Korea, I put here between China and Japan. So it's similar to your sandwich theories. So China and Japan and Korea may be located here, and the question is where Korea is going from now on. And these are all based on my very, very rough, very, very hypothetical analysis of histories of each regions. Because of the history difference, each individual region may have different types of organizational capabilities. Korean has very different organizational capability than the Japanese. So the kind of products that Koreans are very strong, like semiconductors, shipbuilding, and some part of sheet steel, are very different probably from the Japanese. So there will be competition between Chinese and Korean and Japanese and Taiwanese, but through this competition, this kind of difference also will reveal itself. So in this hypothesis, Chinese companies, because of history, were very modular. They are very good at modular products or quasi-modular products. So, for example, look at the cars. Car is not car. This car is German cars. It's very, very integral. This car looks also integral, but actually it's very modular. What's inside is Mitsubishi engine and the Italian design and so many other sort of components, which is more modular. It's more like a bicycle. This car is more modular, very, very modular. But, so this is a typical Chinese local cars, which is very modular, very different from Korean cars or Japanese cars, which are integral. Okay? But how about this? This Indian car, Tata Nano. I test drove this car. I took a look at this car directly. My conclusion is that this car is integral. Very different from Chinese cars in terms of architecture. So we have to deal with this car very differently from Chinese cars. This is not another Chinese car. It's low cost, yes, but this is very integral. So Indian cars and Indian motorcycles are both very integral, closer to probably Japanese. And the Korean cars are used to be very modular, but now it's getting more integral. And Chinese cars are still very, very modular. So we have to really take a look at difference of the architecture, and then based on this knowledge, we have to decide where to design, where to produce, what kind of products, and that is global manufacturing. So the conclusion is global manufacturing has to take into account this kind of architectural analysis, in very detailed analysis, and capability analysis. So conclusion is this. Well, how about Korea? This is my rough hypothesis, which you may or may not agree. So please give me some advice. But my hunch is this. When Chinese companies become rich, cash rich, they will also become confident that they can make capital-intensive modular products. In Korean companies, now Chaebol type of companies are very strong in capital-intensive modular products because of the history again. Chinese companies now are very strong in labor-intensive modular products. But when they become cash-rich, they may become also confident and very competitive in the same areas as Koreans. Okay? So Korean companies may be attacked from behind. And if you want to avoid that kind of direct competition with Chinese companies, then you may want to shift to integral areas. So capital-intensive integral architecture products, which means that there will be more competition, I think, between Japanese and Korean companies in this area. And it's already starting, I think. Of course, cars and some of the material industries and electronic industries, it's happening. Well, I'm not saying that it's a bad thing. It's a good thing, actually. Because this kind of tough competition between Korea and Japan, we raise the capability of both sides. You know, what's important is the notion that this is not sports. Okay? This is not sports. If it's a sport, if Korean soccer team wins, then Japanese soccer team lose. It's a win-lose situation. Always, if we win, you lose. If you win, we lose. No? So it's absolute advantage game. But this is comparative advantage game where both can win. The companies are, competing with each other, beating each other. But as a whole, country by country, if you have this kind of competition, then both productivity goes up. That means both living standard goes up. That means that we are both winners. So my conclusion here is that, yes, there will be more competition, I think, between Korea and Japan. And also there will be more sort of articulation of what Korean companies are good at and Japanese companies are good at through this competition. But this is not a bad news, because now this is a time when we compete with each other, but we can learn from each other in a more productive way. This is my way of looking at some of the Korean companies' strength. History matters, and products are simpler than the Japanese over-engineered products. And more investment in global market creation. For example, when I visited India, Hyundai India had about 30 expatriates. Most of them spoke Tamil language. There is a Japanese company, Toyota India factory nearby in Bangalore. I visited there also. There, a few people speak English. All speak Japanese. Expatriates. Okay? Some speak English. Few speak Hindu. Zero. Absolutely zero in Tamil language. So, in this case, Toyota has a lot of things to learn from how to sort of create the market, like Indian market and other newly developed markets. Hyundai is much more advanced than Toyota in this particular aspect. So, while there are many things still, I think that Hyundai can learn from Toyota. Now Toyota can learn a lot of things from Korean companies, okay? Because Korean company has this kind of strength, and that is a source of their competitive advantage. So now I think is a good time to compete severely and learn severely, mutually with each other. And that again is not a bad news. This can be the source of a win-win game for both sides. So in this eastern part of Asia, I think there is a chance that all countries can become a winner. Okay? So we all improve industry performance. We all win. That is the last comment that is based on my sort of theoretical framework. I'm sorry about the long lead time for myself. Thank you very much.
Thank you very much, Professor, for your enlightening presentation. 대단히 감사합니다. 교수님께서 워낙 열정적이셔서 아마 밤새 이야기를 하셨을 것 같습니다. Just we'll be able to take one question, just in the interest of time. 교수님께서 다음 일정이 있으셔서 안타깝지만 질문 하나만 받고 이번 세션을 마무리해야 될 것 같습니다. 질문 있으신 분 손 들어주시기 바랍니다. 마이크를 좀 가져다 주시기 바랍니다.
안녕하십니까. 대진대 4학년에 재학 중인 최아영이라고 합니다. 잠시만요. 하지만 봤을 때, 私は 최아영 또 모시마스. Just a little short self-introduction, and it is a very great opportunity to listen your speech, presentation, and as you say, the definition of the monochikuri is related about design information between product resources, and it is related with the design, but I just have some questions because I'm not sure that the definition of the monozukuri, as my personal opinion, I know about the monozukuri. Monozukuri is related about the quality, perfect quality. It is related with monozukuri, and I don't know why that monozukuri is related with the design. So please, please explain.
Okay.
Yes.
Yeah, good question. Thank you. Well, I'm sorry. Is it okay? Yeah, I think that's a very good question. I would say that, well, first of all, design is not just industrial design, okay? Engineering design as a whole, okay? So the big concept. It's not very small, concept, but big concept. And quality, yes. I mean, quality is very important part of monozukuri in terms of performance. But I said monozukuri is all about creating good design and its good flow to the customers, okay? Good design means good design quality, okay? Quality usually has two aspects, manufacturing quality and design quality, okay? And design quality is a part of this good design part. Good flow, again, means accurate, fast, and smooth, and efficient flow of design information to the customers. This is all about, the target of Toyota system, okay? So it naturally includes manufacturing quality, because good flow means good manufacturing quality, good and short throughput time, short lead time, and smaller inventories, smooth and rhythmical flows. All these things are part of the good flow. So what you said is perfectly right, but you have to take a look at broad views because it's not just quality. Okay? Sometimes it's lead time, sometimes it's cost. Okay? So for example, one factory in Japan can compete in cost against its Chinese factories. Then they may try to find a business model which makes lead time very important. So for example, one company called Fuji Xerox, the Xerox company, had almost all of the factories outside Japan now. Okay, so the problem is that how to survive, make the Japanese Fuji Xerox factory survive, okay, despite the fact that they are not competing well in cost. The Fuji Xerox people found a new business model of recycling, okay, for global warming and for the global environment. It's better to recycle all the copy machines from 7-Eleven, back and forth. Okay. They created this business model, and in this business model, it's absolutely important to have a short lead time. Cost is secondary in this case. Lead time is absolutely the most important thing. And they created nice, factories where all the machines are coming back to the factories. They are tearing down. The people tear down. The people just decompose the product in a very efficient way. And then pick up the usable parts, add new parts, and go quickly to the assembly line. Immediately assemble the parts, and go back to the 7-Eleven shops. And in probably several hours, they just, the old machine comes, new machines goes out. Okay, very short lead time. And this way, this factory could survive in Japan, despite the fact that in cost they cannot survive. So I think, this is a kind of a wisdom that everybody on the shop floor are now trying to use. If you can't compete in cost, you may be able to compete in quality. You may be able to compete in the lead time. But all these things are based on the notion that, after all, we are creating good flow of good design to the customers. Okay, so what you said is right, but you can broaden your views. Then it comes to the manufacturing ideas in a broad sense, and that is monozukuri idea. Thank you.
네, 대단히 감사합니다. 자, 열정적인 강연을 해주신 우리 후지모토 다카히로 교수님께 큰 박수 부탁드립니다. Thank you very much, Professor Fujimoto Takahiro. Thank you very much.